Hello everyone, myself Shinde V.G., working as Assistant Professor at Department of Nanoscience and Nanotechnology, KTGM College, Nasik. Today, we are going to discuss T.Y.B.Sc Semester 3rd, paper number 2nd, that is the course of Nanophysics. In today's lecture, I have discussed the laws of thermodynamics. Now, in this lecture, we have to study the laws of thermodynamics outline. They have the fourth law of thermodynamics. Now, the first one is zeroth law of thermodynamics. Next, first law of thermodynamics. Next, second law of thermodynamics. And last one, third law of thermodynamics. Now, the first one discussed with zeroth law of thermodynamics. When a hot system or hot body is right in thermal contact with a cold system or cold body B, heat flows from A to B, and after some time the flow stops. The bodies are then said to be in thermal equilibrium with each other. Means the hot body A in a thermal contact with a cold body B. The heat flows from A to B, and sometimes heat flows stop. These two bodies A and B are the thermal equilibrium with each other. That's why the statement of zeroth law of thermodynamics is, if two systems A and B are in thermal equilibrium with a system C, then A and B must also be in thermal equilibrium with each other. This law is the basis of thermometry. This is the statement of zeroth law. This law is stated that the A and B in thermal equilibrium with the system C. A and B, these two systems, is a thermal equilibrium with system C. Then the A and B is also thermal equilibrium with each other. That is the zeroth law of thermodynamics. As shown in figure, we have showing that two figures, figure A and figure B. Figure A is show that the A and B are separated by the insulating portion. These two systems or two bodies are separated by a insulating portions. And C system is a thermally contact with system A and system B, and this put up in system by the adiabatic walls. And system B is showing that the insulating portion is removed, that and the system A and B and system C, they have a thermally contact with each other. When consider system 2, system A and B insulated from each other but in good thermal contact with a common system C. Means system A and B, they have insulating portion or insulating each other, but the thermally contact with the system C. Thermally contact with system C. System A and B will attain a thermal equilibrium with a third system as shown in figure A. Thermal equilibrium by the third system C as shown in figure A. Now, if an insulating portion is removed and system A and B are right into a thermal contact as shown in figure B, we find that there is no further change. they have figures showing that the insulating portions are removed, that and A and B and C, these systems have a thermally equilibrium or thermal contacts. This means that the system A and B are also in thermal equilibrium with each other. This is known as zeroth law of thermodynamics. Means these two systems A and B are in thermal contact with each other. That's these two systems are also in thermal equilibrium. That's how thermal equilibrium with another or each other. That is known as zeroth law of thermodynamics. Now, discuss with first law of thermodynamics. This is the law of conservation of energy. This law is also known as laws of conservation of energy. A system contains a large number of particles will always have in its equilibrium state an internal energy Q due to the moments of particles consisting the system and their interactions. If an amount of heat dq is supplied to the system, the change in the energy is given by dq is equal to du plus dw. That is the equation number first, where dw is a work done by the system and the du is a internal energy of a system. Statement of first law of thermodynamics. The amount of heat given to a system is equal to the sum of the increase in internal energy of the system and the external work done. Means the amount of heat given to a system is equal to the sum of the increasing internal energy of the system and the external work done. That is known as the first law of thermodynamics. And the laws of conservation of energy is the energy may be neither created nor destroyed, but it can be transferred from one form into another. Means the energy is not created or not destroyed. This energy is from one form to another form. That is known as laws of conservation of energy or first law of thermodynamics. The relation equation first is mathematical expression for the first law of thermodynamics. dq is equal to du plus dw. That is the equation number first. This is the first law of thermodynamics. dq dw for the heat absorbed and the work done. dq is heat absorbed and dw is work done. Suppose a gas is contained in a cylindrical vessel with a piston of cross section A. The force acting on a piston due to the mean pressure or mean value pressure is mean A, means cross section A, system cross section A or piston cross section A. That's mean pressure A. The work done by displacement the piston through a distance dx is the distance is mean value A dx is equal to mean value dv. That's how, hence we can written equation first as dq is equal to du plus mean value p dv. That is the equation number second. This is the first law of thermodynamics. That's how pressure and dx is a distance from piston through the displacement of the applying work done. Now discuss with the second law of thermodynamics. This law is expressed in several ways, one of them being. This law is several ways explained that. But this one of the form is being no process is possible whose sole aim in the transfer of heat from a colder to hotter body. Means cold body to hot body heat transfer. This process not a develop. This is known as second law of thermodynamics. There is yet another way in which this law can be expressed. From the first law of thermodynamics, we can written here dq is equal to du plus p dv in value p dv. That's divided by t. This equation is divided by t. That's have written here dq upon t is equal to du upon t plus p dv upon t. That is the equation number first. The specific heat Cv is a function of state and is given by the Cv is equal to du upon t or du is equal to Cv dt. That's why from the equation of state of gas is a PV is equal to RT and that is P is equal to RT upon V, where R is a gas constant. Using equation first can be written as dq upon t is equal to Cv dt upon t plus R dv upon V is equal to d in bracket Cv ln t plus R ln V. That's since this equation right hand side and left hand side is exact differential. This is the exact differential. The function of the state whose differential is dq upon t is called as entropy of the system and is denoted by S. Thus, the dq upon t is called entropy of the system and denoted S. That's why the ds is equal to dq upon t. That's why the statement of second law of thermodynamics is when a system goes from one state to another by absorbing heat slowly. Quasi-statistically, at a constant temperature, its entropy increases. That is the statement of second law of thermodynamics. Now, discuss with the third law of thermodynamics. The statement of third law is the entropy S has a limiting value S0 as the temperature tends to 0. That's why the S0 is independent of nature of the system and its numerical value is not fixed at 0 Kelvin. But it is convenient to take it to be equal to 0. The third law of thermodynamics is also known as Nanoscience heat theorem and is best developed and interpreted using statistical mechanics. That's the third law of thermodynamics. This topic is over. In this lecture, I have studied the laws of thermodynamics. First one, the zeroth law of thermodynamics. Now, next, first law of thermodynamics, second law of thermodynamics, and last one, discuss with the third law of thermodynamics. Thank you.